have liquid water. We know, for example, that meteorites have come to Titan and hit the surface, generating heat and bringing energy with it, and perhaps for certain amounts of time, then that would mean that there could be pools of liquid water there. So it's really interesting to think about and speculate about the possibility of life in other parts and other locations of our solar system, and Titan is a very interesting place to look into those questions, and that's why we're going there.
Once the spacecraft gets to Saturn, how will it collect data? Will it use rovers like the Mars rovers?
No, actually, it's going to be rather different from the Mars mission. We're not sending rovers like Spirit and Opportunity. It won't be trundling around on the surface like we did on Mars. First, we're sending the Cassini spacecraft, and it's an orbiter, and when it reaches Saturn, it'll actually spend the next 4 years there, kind of doing a grand tour through the Saturn system. And one of the things it will do is about 40 flybys near Titan, collect information, kind of a big picture view of Titan. But then in addition to that, we have a Titan probe, Huygens probe, and that was developed by the European Space Agency, and it'll drop down through Titan's dense atmosphere and all the way down. The instruments will be taking all kinds of measurements like the density of the atmosphere and the temperature and altitude and things of that sort. And of course, it's going to be taking a lot of data, a lot of information about the chemistry of Titan's atmosphere, what kinds of things are there and how much. And it'll take about 2 to 2.5 hours to get all the way down through the dense atmosphere. We don't know what it will land in, but it will be able to stay on the surface and then in its local area kind of take some measurements and also radio that information back to the orbiter and back to Earth.
The next generation of science missions to Titan will probably be much different than the missions of today. Because little is known about the moon's geology, one type of mission concept recently developed by NASA would rely on a dirigible type craft to move through Titan's atmosphere, taking multiple measurements over time. This blimp would float above the surface and deploy a small probe to sample Titan's atmosphere, methane crater lakes, and crater rim ice. The probe would be able to analyze the samples on the spot and then relay the information to scientists back on Earth. With Earth nearly 800 million miles away, the probe would need to be almost completely autonomous. This type of craft could conceivably float through Titan's atmosphere for many months, gathering valuable evidence about Titan's chemistry and geology and what that means for us back on Earth. Realistically, what are your expectations? Are you expecting to find life on Titan?
Scientists try to be very objective, and only have attitudes and opinions based upon what we know, of course. And so I think a lot of people are holding back and saying, I don't expect to find life there. It's too cold. Even though we have extremophiles here on our planet that can live in very dry or very cold conditions, it's really cold out there, and there isn't liquid water. So we're not expecting to see anything there. But the nice thing would be is if we could find, I think a lot of people would be very, very happy if we saw some serious complex organic chemistry going on. Clearly prebiotic chemistry would just be wonderful. Going to other destinations in our solar system and then gathering this kind of information could really help us understand how our planet formed and how life originated on our planet. And these are really profound questions, not just to scientists, but to everyone. And so I think it's really interesting and great that NASA can send spacecraft and gather these kinds of data to help us answer those kinds of questions.
After a nearly 7-year journey, Cassini-Huygens entered orbit around Saturn on June 30th, 2004. On Christmas Day of 2004, Cassini released the Huygens probe on its journey toward Titan. Finally, after a 20-day ballistic freefall on January 14th, 2005, the Huygens probe entered Titan's atmosphere. It deployed parachutes and began 2.5 hours of intensive scientific observations while transmitting data to the Cassini spacecraft. After making contact with the ground, the first ever pictures of Titan's surface were finally seen back here on Earth. Coming up, we'll find out more about robotic missions that will pave the way for humans to travel to other planets. But first, did you know that the Cassini mission is studying more than just Saturn and Titan? In fact, recent images by Cassini have shown spectacular evidence that another one of Saturn's moons, called Enceladus, is geologically active. Cassini's cameras have captured pictures of jets of fine icy particles streaming from the moon's south polar region. Because this moon is so far from the sun, it is believed that the energy source for the geyser-like activity is due to internal heating by perhaps radioactivity and tides. Researchers hope to learn more on subsequent flybys by the Cassini craft.
One of NASA's stated goals is to go back to the moon and explore Mars and beyond. To reach these goals in a safe and economical way, NASA planners are using an approach that will first use robotic missions to test equipment and techniques that will eventually be used for human missions. These robotic missions will expand our knowledge base and will help us focus training that will prepare humans for the next step of exploration. To help us understand how this will work, Jennifer Pulley spoke with Mark Saunders at NASA Langley Research Center in an earlier episode.
The history of the space program is very impressive. Since its beginnings in 1958, NASA has grown to be one of the most revolutionary agencies in recorded history. With President Kennedy's goal to reach the moon by the end of the 1960s,
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
and with the backing of the American public, technologies that would have seemed impossible in earlier years were being developed and perfected in record time. This drive and determination has never left the agency. Today, a new generation of researchers are gearing up for the next big step: crewed missions back to the moon, to Mars, and beyond. However, major challenges await. Questions of crew safety, medical concerns, the need for new technology development, and a host of other issues make this goal very daunting. To lead the way, robotic missions are being planned that can give researchers a better idea of what human crews can expect in space. I spoke with Mark Saunders at NASA Langley Research Center to help us understand how these robotic missions will work.
Our robotic missions are actually precursors to what it is that we're trying to accomplish with humans. They're the probes that we're sending out to help us understand what it is that we're getting to when we send people there. They're testing new systems, collecting data about what's actually happening on the planet's surface as well as the atmospheres. We want to make sure that we understand this to the maximum extent so that we're always sending humans in a safe way.
So Mark, what is the definition of a robotic mission?
People think of robots in many different ways, and those of us in the agency actually do that as well. We're making spacecraft. You know, as an example, the Hubble Space Telescope is a robotic spacecraft. It's actually very smart, but we talk to it a lot with people on the ground that kind of tell it what to do on a periodic basis, usually in terms of minutes. But as you get robots that are going farther out into the solar system, they need to really operate a lot on their own because it takes a long time for us to talk to them. So radio waves go out there and it's hours before we hear back from them. So they're actually operating pretty much by themselves.
What can we expect from robotic missions in the next few years?
As all of us have been watching, the Mars exploration rovers have been doing a great job on Mars. Cassini is at Saturn with its Huygens probe. We're planning the next series of missions, both for scientific purposes, as well as to prepare us to send people on to the moon and then on to Mars.
The first of these planned robotic missions will be going back to the moon. The goal is to have these robots pave the way for humans by mapping the lunar surface, surveying potential landing sites, and searching for water ice. Now, tapping into water ice could be very important because human explorers could not only convert it into oxygen and hydrogen for breathing, but they could also use the gases to produce rocket propellant for future missions to Mars. In short, these robotic missions will allow NASA planners to design the needed equipment for astronauts to live and work on the moon, while also helping them prepare for future missions to Mars.
One of our biggest concerns is always making sure that our missions are as reasonably safe as possible for the human, as the human participates in it. So when we send out robotic missions to the moon and to Mars, we're trying to understand what the moon and Mars represent in terms of their environmental conditions, what they're made of, are there any elements there, both in the atmosphere on Mars or on the surface of the moon, that might have some toxic properties, and as well as their physical characteristics, their composition, so that we understand when we build a human spacecraft to go with humans in it, that the system that we send is compatible with the environment that it's going to be in. So that's one major point. The second point is that like the explorers of old, to the degree that we can use resources that we find, we want to be able to use those resources to help sustain them. And doing this, by the way, reduces the cost. So although it may cost us some to develop the technologies now, when we go, if they don't have to take stuff, it's, we don't have to pay to get it off the surface, and we're not paying to get water off the surface if we can find water there.
So is most of the technology already developed?
Technology is actually the key to what it is that we're trying to do. New technologies will enable us to be more efficient in how we go, allow us to actually take lighter weight systems, cheaper systems, more reliable, safer systems, so that the overall cost to the American taxpayer is dramatically less than the Apollo program.
And we've discussed going to the moon, going to Mars. What other destinations do you foresee for robotic missions?
Obviously, asteroids. And everybody's familiar with asteroids. We certainly have quite a few disaster movies around them. But there are a lot of scientists and engineers who believe that asteroids have the potential for resources that we might actually mine and use. And so one other destination are asteroids. What our strategy is to begin to make small steps towards the moon, to Mars, and then on to destinations beyond that. So we're going to gradually, over the next decades, push our human exploration beyond the boundaries as our robotic explorers find out new things about what's interesting out there.
When humans go back to the moon, they will almost certainly be traveling in vehicles that look very similar to the Apollo spacecraft of the past. These next-generation vehicles will use an improved large blunt body capsule that will have more than 3 times the volume of the Apollo capsules. Coming up, we'll look back at the beginning of the Space Shuttle program. But first, did you know that one major difference being planned for next-generation missions to the moon will be the number of crew members on the surface of the moon? During the Apollo program, only 2 crew members would take the lander down to the surface, while 1 crew member stayed in lunar orbit to maintain the ship. The new system will allow a 4-member crew to transfer to the lunar surface, while automated systems will maintain the crew spacecraft in orbit.
Towards the end of the Apollo program, NASA officials were already thinking about what would be next for the American space program. At that time, the rockets used to place astronauts and equipment into space were designed to be used only once. Although effective, NASA planners decided that they needed a system that was less expensive, reliable, and perhaps most of all, reusable. The idea of a reusable space shuttle that could launch like a rocket and land like an airplane was appealing, and would soon change the way astronauts were traveling into space.
The space shuttle was born on January 5, 1972, when President Richard Nixon authorized the development of reusable vehicles for space exploration. The project became known officially as the Space Transportation System, or STS. It was based on a piloted spacecraft boosted into orbit by a reusable launch vehicle that could return to Earth like an airplane, ready to be used again on short notice. This new vehicle consisted of 3 primary elements: a delta-winged orbiter spacecraft, 2 solid rocket boosters and 1 external fuel tank. Over a 10-year span, 5 orbiters were built, including the test vehicle named Enterprise and the 4 space orbiters, Columbia, Discovery, Atlantis, and Challenger. On April 12, 1981, after years of testing and construction, the first shuttle, Columbia, reached orbit piloted by astronauts John Young and Robert Crippen. The first 4 shuttle flights were collectively called the Orbital Flight Test Program and demonstrated how the spacecraft performed under real spaceflight conditions. During these first 4 flights, NASA tested the shuttle as a launch vehicle, habitat for crew members, freight handler, instrument platform, and aircraft. After the 4th landing, NASA declared the shuttle ready for operation. Since that time, the shuttle program has performed well over 100 missions and has accomplished a number of monumental achievements. In June 1983, Sally Ride became the first American woman in space. The shuttle launched the Magellan spacecraft to Venus, the Galileo spacecraft to Jupiter, and the Ulysses spacecraft to study the Sun. The shuttle also has deployed the Hubble Space Telescope, the Gamma Ray Observatory, and the Upper Atmosphere Research Satellite. Another key milestone came in 1998 when astronaut John Glenn, the first American to orbit the Earth, returned as the oldest man ever to reach space as a member of the crew of Discovery on a 9-day mission. The shuttle has also been instrumental in constructing and outfitting the International Space Station, while also being used to carry large payloads to and from orbit and perform servicing missions on satellites. The design, now approaching its 3rd decade, is still state-of-the-art in many areas, including computerized flight control, airframe design, electrical power systems, thermal protection system, and main engines.
Even though the sophisticated shuttle program suffered the devastating losses of the Columbia and the Challenger, its successful missions have made great strides in space travel and exploration during its short history. More than 100 documented NASA technologies from the space shuttle are now incorporated into the tools we use, the foods we eat, and the biotechnology and medicines used to improve health. Although plans are now in the works to retire the fleet, the space shuttle program will forever hold a special place in the history of space travel, not only for its unique design, but for the history and technologies it brought to all of us.
Even though the space shuttle will eventually be phased out, NASA planners still hope to use the proven shuttle main engine and booster technology on next-generation vehicles. Our final story focuses on the advent of GPS. In recent years, the GPS receiver has been one of the most useful tools for professional pilots, drivers, and seafarers. These receivers use geospatial data to identify geographic locations and characteristics of natural and man-made features on the Earth.
These receivers are also being used by hikers, golfers, and fishermen for recreation purposes. However, many people who use this technology still don't know exactly how it works.
Our Johnny Alonso finds out how this complex system helps keep many of us on track and on schedule.
Trying to figure out where you are and where you're going has always been a challenge. Navigation and positioning are crucial to so many activities, and yet the process has not always been easy. Thankfully, the days of navigating by celestial means or landmarks are long gone since the introduction of GPS, or the Global Positioning System. So what is GPS? For some answers, I spoke with Dr. Kevin Dutton at NASA Langley to find out how it works.
GPS stands for the Global Positioning System, and like the name suggests, it's a system to find your location anywhere on the Earth or near the Earth's surface. And the way it does that is by using radio frequency broadcasts from orbiting satellites.
Can you tell me why GPS was originally developed?
It was developed by the Defense Department to meet all of their navigational needs. For example, aircraft and ships at sea. And now even individual soldiers carry little receivers like this in the field to find out where they are.
The Global Positioning System consists of a constellation of 24 satellites and their ground stations working together. GPS uses these man-made stars as reference points to calculate positions accurate to a matter of meters, and in some cases centimeters. As long as you have a GPS receiver and a clear view of the sky and a map, you'll never be lost again. Today, GPS is finding its way into cars, boats, planes, construction equipment, farm machinery, even laptop computers. So how does the system work?
Let's say you're backpacking and you have a receiver with you. You're going to turn on that receiver. Now the GPS satellites are constantly broadcasting a signal, all 24 of them, but above you at any one time there's only 12 available, and then the other 12 are on the other side of the Earth.
Okay.
So your receiver is going to listen and try to find at least 4 of these satellites directly above you, and then it's going to determine a range to each satellite, and it's going to use those ranges and the known locations of the satellites, and it's going to do some mathematical calculations and a process called trilateration, and it's going to figure out where that GPS receiver is. That'll also give you altitude, and it'll give you speed and the direction that you're traveling in.
A standard GPS receiver will not only place you on a map at any particular location, but will also trace your path across a map as you move. If you leave your receiver on, it can stay in constant communication with GPS satellites to see how your location is changing. With this information and its built-in clock, the receiver can give you several pieces of valuable information like how far you've traveled, how long you've been traveling, your current speed and your average speed. Also, the estimated time of arrival at your destination if you maintain your current speed.
There's a lot of uses that they hadn't really thought about when they developed the system. For example, later on it was discovered that if you put multiple antennas on a vehicle, like an aircraft for instance, you could actually get attitude. You could figure out its orientation and whether it was rolling or pitching or yawing. Other things that they didn't realize they could really do were, for instance, seismologists use it for earthquake detection and to find out when tectonic plates are actually shifting apart. It's that good.
Something else.
Yeah. Very interesting.
Sure. So that's how it works. So the next time you want to know where you are or where you're going, don't reach for a map. Reach for your GPS. Now, which button is it here to press for a date for tonight's gathering at church?
That's all for this edition of NASA's Destination Tomorrow. Thanks for joining us. I'm Steele McGonigal.
And I'm Kara O'Brien. For all of us here at NASA, we'll see you next time.